Alright, hello everyone. Welcome back. Today we are doing a little bit different. Not playing a game, necessarily, but this little fun little puzzle we gonna do today. It's called Advent of Code. Yeah, I've done the previous years, at least some of it. Never actually finished one. But yeah, I'm gonna be doing this year's first 5 days. It should be pretty quick. I hope it doesn't take that long. Otherwise, I don't know. I might be outed as a fraud. But yeah, 2021. Let's go. Day 1. I'm gonna be doing this in Python, and I'm hosting on Replit. Just for animosity. That's how you say it. All right. Day 1. Sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights because, of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost the signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instinct tells you that in order to save Christmas, you'll need to get all 50 stars by December 25th, collecting stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. 2. Alright, the second puzzle is unlocked when you complete the first. Alright, yes. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, 210, 200, 207, 240, 269, 260, 263. This report indicates that scanning outward from the submarine, the sonar sweep found depths of 199, 200, 208, and 210, and so on. The first order of business is to figure out how exactly the depth increases, just so you know that you're dealing with. Just to know what you're dealing with. You never know if the keys will get carried into the deep water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There's no measurement before the first measurement in our example above. The changes are as follows: 189, no previous measurement. 200 increase, 208 increase, 210 increase, okay, yeah. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurements? Wait, what? Are we just counting them? Is that it? How quickly the depth increases. Okay, so yeah, we click this to get our puzzle input. Get a quick line of numbers, huh? So let's just copy and paste those into a new file. How do we do that? Add file. Input. Text. I'm actually not sure if we can get files like this. So let's with open input. That'll be the file name. So I guess we should write the file name. Input file equals input text input file. And then I guess just read as F. And then I think, wait, hold on. Why is tab 2 spaces? Hold on. I need to configure that. That is not right. 4. There we go. Much better. Okay. And then input equals f.read. Right? Wait, read. I think read should work. And let's try printing inputs. So let's see if that runs. Okay, there we go. Alright, so we start off at... Is that right? I guess there's a limited number of lines, huh? Start at 180. Okay, I see. Lower the music a little bit. So now, what do we want to do? We just keep track of when it increments, right? So, you can delete this line. Current. Actually, input should be an array. So, current equals input 0. Current depth. We should make this a little bit more descriptive. Okay, and then I guess index. Just go I equals 1. There we go. And then for... Actually, we don't need that, do we? Yes, we don't. Yeah, we don't. For I in range 1 to input, length of input. Input, okay. What do we want to do with this? Honestly, we don't even need this. Really, but sure. We're just gonna do it like this. Okay, we need to count how many times it increases. Right, okay. Number of increase equals 0. So we're gonna first do a check if current depth is less than input I. Right? Less than current I, then num increases. Plus equals 1. Okay, and then regardless, we're going to increment current depth. So current depth equals input I. And then finally we print number of increases. Run. Alright, let's clear it first. Run. 4,697. 4697. What? Wait a second. Wait, hold on. Okay, let's just do it with the test input now. I might have done that a little bit wrong. I mean, yeah, clearly I did. If current depth is less than input I, number increase plus equals 1. Did I? Okay, let me just make sure I put in the right number. 4697. Yeah, no, it's probably not gonna work. Oh, wait. Too recently. Okay. Well, let's just let's grab these. Make sure it's working correctly. Test. Save. I think it saves automatically. So we're just gonna copy this line, paste. 17. Okay. Yeah, there's something clearly going wrong. Length of input. Input 0. Okay, let's just print print current depth, and that should give us bit of an indication. What's with all this? Something funky's going on. Oh wait, I have an I think I know. I need to change this to int, right? Because they're all strings. Okay, that should make sense. Should make more sense at least. Int. Okay, right? Actually, let's clear. First, run. Trace back. Invalid literal for int. New line. Wait a second. Which one? We got 199. Oh my god. Okay, next. Equals this. To clean up a little bit. Next to I mean, it's not going to solve the problem, but need this little clear things up. Okay, right, line 10. Wait, what? Line 11. Line 11. Maybe I can strip? Or is it, I forgot what's it called. Is it strip? R strip? No. Oh, that's, it is strip, isn't it? R strip would be the right side, so let's try that. Wait, what's my input? Oh, wait, what? Oh, right. No, I have to read the lines. That's what's happening. Oh, that's what it is. Okay. Let's see. Read lines? Read lines, maybe. That might work a little bit better. There we go. Okay. I forgot which one this was, but I got it in the end. Okay, so what do we not need? I think we need most of this. I can probably delete this now. Maybe I should comment some of the code, huh? So it was first number, iterate, and compare next value. Yeah. So that one's pretty self-explanatory. I don't think I need to do that. Increment if greater. And then set next number. Right. 1529. Okay, that should be right now. I was thinking the first one was a little too high. That's the right answer. You are one gold star closer to finding the sleigh keys. Yeah, I understand the reason why it did run the first time. It's because you can compare the values of each character through like ASCII values. So a new line is also one character. You compare that character to like this one, the one. Yeah, it's a little strange. But part 2, let's go. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of the 3 measurement sliding window. Again, considering the above example. A, B. Okay. So this would be 1. This would be the next. This would be the next. Next. Okay. Yeah, let's move over just slightly. Start by comparing the first and second 3 measurement windows. Measurements of the first window are marked. Do we start here? Their sum is 199, 200, 208, 607. The second window is marked 200, 208, 210. Its sum is 618. The sum of the measurements in the second window are larger than the sum of the first, so this first comparison increased. Your goal now is to count the number of times the sum of the measurements in a sliding window increases from the previous sum. So compare A with B, then compare B with C, then C with D, and so on. Stop when there aren't enough measurements left to create a new 3 measurement sum. Okay, so we ignore this part and we ignore this part. Yep. In the following example, the sum of the 3 measurement window is as follows. Right. Okay. So in this example, there are 5 sums that are larger than the previous sum. So I think, actually, let's, rather than doing main, let's do, part 1, pi. Right, let's move all this over. And then this would be part 2, pi. Part 2. Okay. So now with we gotta do the windows. The windows. We're gonna do this. I'm thinking of a little convoluted situation here where we do actually keep track of all 3 numbers. Does this make sense? I have no idea. Okay, so we do 1 to 3, or okay, first 3, and this one would be 1 length of input minus 3, right? 1, 2, or is it 2? Hold on. Well, I have no idea, but we can test it. So it's gonna be a little inefficient. We're gonna be calculating each one multiple times, huh? We could store all of them if we want. All the sums. So we can make like a new array with all the values. Or we can have like previous. Yeah, the only thing we need to keep track of is the previous one. So previous sum, or window, I guess. Previous window equals 0. Or I guess null in this case. None. Right, in Python it's none. Okay, so if you I'm not sure if it's 1 to 3. Wait, length of input minus 3 or minus 2. It's getting a little hectic here. I think it's minus 2 actually. We'll see if we run into any sort of actually current depth. Actually, okay. It's gonna be a little bit different. So previous window would just be current depth, yeah? And you start from 2. Be 2, 3, and 4. And then the first one would be 1, 2, and 3. There's probably more efficient ways to do this, but it's okay. Actually, wouldn't it be more efficient just to look at, was it this number and this number? Yeah? Or wait, am I delusional? It'll be A and D. So this and this. Yeah, the difference is 11. Oh. Wait, what? Yeah, because these two are the same. B and C are the same as this B and C. So we don't actually have to add them up. We just have to look at A and D. Oh, okay. Yeah, that makes it a lot easier. Okay. So current depth, and then so -2. Whatever. This is fine. When I said it's a little inaccurate, I was thinking they'd do like averages instead, rather than just Windows stuff. I swear the music's getting louder and louder as we're going. Okay, so rather than next num, it would be I plus 2. It'll be, wait, 3? 1, 2, 3? Yeah, 3. Let's do the test file. Yeah, nope. I hope nothing incriminating showed up there. Okay, let's run this. Died unexpectedly. Oh, no such file. Okay, let's go to shell. Yeah, we have to do this now. Python parts to pi. I plus 3 list index out of bound. So I think, yeah, I think I got that wrong. Is this one? Try it again. 5. And does that match? 5 sums that are larger than the previous. Okay. Yeah, so let's try it on the actual input now. That's safe? Oh, I'm hoping it's saved. Okay. 1526. That sounds a lot like our last one. Hmm? 5. Okay, it didn't work on the first one. It's too low, it says. Am I doing that right? So it would be 199, 210, 200, 200. Oh, it's not next num. Oh, yeah, okay. No, it'd just be the number, this number next. Actually, we don't even need strip anymore. If I'm not mistaken. Input I. And then I think we're good. Damn it. Try that again. Oh, int. There we go. Almost ran into the same problem. And I keep doing that. this run button. I just delete it. 1605. That sounds a bit better. No? Too high now. Too high. Does it work on the... Actually, how did that even work on the first one? Let's see. Let's try that again. 6. Eh? Eh? Okay, maybe I should, let's print. Let's print the numbers that we're comparing. So we're gonna print... Current. Print. Or current print next. And we'll this should sort things out. You know, if I run the right file, that'd be great. Okay, so 199, 200s, 200. You know what? Should be 210, no? Input I plus 3? No, maybe. Oh, it's 2, isn't it? Is it 2 or 3? Hold on. Let's see. No, it is 2. Derp. Yeah, it is 2. Okay. That was right. There we go. That works now. Next number. I don't know if I want to write it in here, explaining my my thought process, but yeah, I think that should work now. Let's run 1, 5, 6, 7. Wait, is that higher than the last one? No, we had 16 something, right? Summit. There we go. 2 gold stars. Okay, that didn't take too much time. Let's keep going. Share, tweet, Mastodon. What's Mastodon? Interesting. Alright. On to day 2, dive. Now you need to figure out how to pilot this thing. You seem like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X, increase the horizontal position by X, down X. Increase the depth by X units, up X. Decrease the depth by X units. Note that since you're on a submarine, down and up refer to your depth. And so they have the opposite result of what you might expect. Okay. Yeah, we can have like negative depth. Wait. No, negative depth would mean we are above sea level, yeah? Okay, no, I think that makes sense. The submarine seems to already have a planned course, your puzzle input. You should probably figure out where it's going, for example. Forward 5, down 5, forward 8. Up 3, down 8, forward 2. Okay, we're only working in 2 dimensions. That should be pretty easy, huh? Your horizontal position and depth both start at 0. The steps would then modify them as follows. Follows. Okay, forward 5 adds 5 zeros. Okay, yep, get it. After following these instructions, you would have a horizontal position of 15 and a depth of 10. Now, multiplying these numbers produces 150. Calculate the horizontal position depth, and you would have, after following the planned course, what do you get if you multiply the final horizontal position by your final depth? Okay, that sounds easy enough. Let's get our inputs. We can delete this now. Copy. Now we go back to my profile. Here is day 2. Right? Edit. Okay, there we go. Yeah, I already set these up beforehand, so this should be fine. Input text. There we go. Now maybe I should put in if we add a new line by accident. That sort of messes up our input. That should be fine. Kinda want to copy the last one, but let's see if we can do it without inputs file equals inputs done text. And we need to add quotes. Oh, did I use double quotes or single quotes last time? File. Read. As F. Oh, this one's the same thing. No! Wait, what? Indent size 4. Okay, that's a little weird. And then input would be... I probably shouldn't be using inputs as a name, since it is it's actually a keyword, isn't it? Yeah. Let's change that real quick. Oh, cancel. It's not main. I actually don't know what happens when it does that. The file doesn't exist. Can I move these? No, I think it's sorted by name. Yeah, okay, inputs. Let's just write in. No, in's not a good name either. Can I use F2? I don't think so. Inputs array. Sure. Inputs array. And that should be fine there. Just need to do the same here. I did use double quotes. Let's fix that. Gotta follow naming conventions, right? Actually, to be fair, I don't always follow like naming conventions. Sometimes I end up using... I guess this one wouldn't be naming conventions. This would be just... How would you say it? Standard? Oh, whatever. I give up. Inputs array equals f dot read aligns. No capital. Very strange. If we're actually following naming conventions, this would be capital. It would be... Actually, what is it called? It's not camel case, is it? I don't know. You would call it. Okay, so just print, make sure we get our inputs correct. That looks right, I think. Okay. Now we need starting positions. So starts, or I guess chord X, chord Y, equal 0, 0. And then we could also use like an array if we wanted to, but this should be fine. So let's see. For I in range 0, length of inputs array, chord. Okay, we're gonna test if it's forward, down, or up. So let's see. If is there starts with in Python? I don't remember. Okay, if inputs array I. Actually, let's instead of doing that. Yeah, we don't need this in particular. We can actually just do inputs array. This would clean it up a little bit. So, and we can print I. That should print each line correctly. We might want to strip it. Just for clarity, maybe. Okay. That looks a little bit cleaner. That's strip. Okay, actually, let's rename this direction or step. Step, each step, not stop, step. Step. Okay. So if step that starts with forward. Actually, well, we know the inputs. It looks like they only go from 0 to, or 1 to 9 inclusive. So rather, we could yeah, we could just get the last digit. In this case, it would be the second last character in the string. That's a little bit cheaty, I think. I think we'll go with okay, we want to let's split the step. So what do you call it? Step. Instruct. I don't know. Here we go. Step instruction equals step dot split. And our delimiter would be space. Or actually, I think if we just do split, you should split it by white space. I think we can we actually do that in here? R \s, something like this. Something like that. I think split just does it for us. So, okay, I'm just gonna comment this one out, and let's print the step instruction. Let's see if it actually gives us what we want. Hold on. Is that right? Step instruction 0. Give us. Oh, I didn't clear the thing. Okay. Right. There we go. Yep, that's what we want. So we get the first index is our direction, and then the next ones are amount of travel. Okay, so now that we have that, actually instead of doing that, we can actually do it like this. So we can have direction, comma, move. So if we do, let's uncomment that, direction equals forward. Writing that, okay. Then we can do x, coordinate x this equals int move. Else, actually, instead of writing all that, move equals move, int move. Okay, that's a bit looks a little strange, but it should be fine. LF direction. Now this would be a great place for a switch case statement, no? So if we move down, then chord y plus equals move, else this is this would always be up. There shouldn't be any other direction. I don't think the submarine can move backwards. Okay, up, chord y minus equals move. And then let's add a little note here. Down is positive. For some reason I've been doing this, adding a space after the comment. And then forward is positive. And then we do print forward X, forward Y. And then we multiply both of those together. X times forward Y. And let's give it a little run. 205. Wait, 20, what? 2058. Wait, 2053, 1033. And then that's our product. So let's see if we got it right. Ah, damn it. Can I not copy this? Copy. Paste. That is right. Let's go. A little smoother than the first one. I think I'm sort of getting into gear now. Alright, part 2. Based on your calculations, the planned course doesn't seem to make any sense. That seems about right. You find a submarine manual and discover that the process is actually slightly more complicated. In addition to the horizontal position and depth, you also need to keep track of a third value aim, which starts at 0. The commands also mean something entirely different than your first thoughts. Down X increases your aim by X units. Up X decreases your aim by X units. Forward does two things. Increases your horizontal position by X units. Increases your depth aim. Multiplied by X. Okay, so we're gonna have an aim value. Increases your depth multiplied by X. Okay, that's not too different. Again, noted that since you're on a submarine, down and up do the opposite of what you expect. Down means aiming in a positive direction. Now the above example does something different. Let's see. Aim is 0, your depth does not change. Okay, down 5. Our depth never changes, right? Or our aim depth does. Wait, what? Is that right? Down 5 adds 5 to your aim, resulting in a value of 5. Forward 8 adds 8 to your horizontal, and a total of 13. Because your aim is 5, your depth aim? Okay. Your depth increases. Does it actually change our depth? Oh, wait. Oh, okay, I see. Aim and depth are separate. Right, yeah. So we need a third variable. I see. So, okay, our depth changes when we move forward. That's the thing. Aim is where you're pointing. If you're pointing down and you move forward, you'll move forward and down, increasing your depth. Okay, yeah, that makes sense. Gotcha. Okay, so we're gonna have a... What do we call this? Aim? Aim equals 0. So for each step, direction, okay. So we're gonna have an aim. I call it aim. Right. Exactly what I named it. Okay, aim would be plus equals coordinate. Wait, no. No, our coordinate x would equal coordinate y would equal. Okay. Plus equals. Right? I don't know, forward adds 2 to your horizontal. Aim is 10. Be 2 times 10 for a total of 6. Okay, got it. So we plus equals our current coordinate y. Actually, no, that's what plus equals says. It'll be aim times move. Okay, and then this would just adjust our aim. Plus equals aim, and minus equals aim. And I think we're done. Actually, what do they want from us? I think we just multiply it. Same thing. Looks right to me. All right, let's give it. Actually, I should undo this. Let's put it in a separate file. But yeah, let's copy. Paste. There we go. Okay, yeah. Let's okay, let's copy this. I don't want to lose all this. It's my first part. Part 1. Part 2. And if we undo, yep, this should be fine. I think that's it. Hey, SDU, thank you for following. Okay, yeah, and then we're gonna rename this as Parts 1. Yeah, pretty similar actually. Well, let's change this in the first one. I think this was a little bit easier. Let's move on to the next one, shall we? Ooh. Ah, my eyes. Sorry, you guys had to see that. Okay. Actually, since I have this already, I'm just gonna reuse this. Don't want to keep writing it over and over. But there we go. Day 3, binary diagnostics. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is power consumption. You need to use the binary numbers in a diagnostic report to generate 2 new binary numbers called the gamma rate and epsilon rate. The power consumption can then be found by multiplying the gamma rate and epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in a diagnostic. What the heck? Okay. So this one, that's 8, right? This was... Do we... Hold on, what? Do we actually have to calculate each of these? Alright. Actually, I think there's a way to change binary to int in Python. I haven't used it myself. But yeah, considering the first bit of each number, there are 5 0 bits and 7 1 bits. Okay, if we're only looking at the first one, right? Oh, the first bit. Oh, okay, no, that's what they want. I see. First bit of the gamma rate is 1. The most common second bit of the number in a diagnostic report is 0. So the second bit of the gamma rate is 0. The most common value of the third and fourth and fifth bits are 1, 1, and 0, respectively. So the final 3 bits of the gamma rate are 1, 1, 0. The gamma rate in the binary number is 1, 0, 1, 1, 0, or 22 in decimal. Epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate, okay, we just invert it. That's not too hard. Yeah, it's been a while since I've used like binary. Okay, by the epsilon rate. Can we use... I think there is bitwise functions in this. In Python. And then we just multiply these two. This might be a little bit more challenging. But out of practice with my binary. But we should get our input first, of course. Puzzle inputs. My eyes. It's blinding. Gotta always use dark mode. Inputs. Not text. Okay. So if we just print that, we should still get it. Gotta always test the code, no? Looks good to me. I didn't need any binary stuff like bitwise operations for this. You can treat them as characters. Yeah, you're not wrong. We still have to convert the number at the end, which shouldn't be too hard. We can write a function for that. I was just thinking if you figure that out like sooner, maybe we can do some. I did that manually. Yeah, maybe we can do some like save some memory. You know, I forgot how we do it in Python. Let me see. Like you can store things as, like you can convert the int to binary number, and that would save a little bit of storage in exchange for some like processing power, which isn't much processing power, honestly. I think it just reads out the bits for you. Okay, let's think. How many bits do we have in each one? I used to write in Perl, and there's a bunch of methods like binary to decimal or whatever. Oh, actually, I think that's should be similar. So each one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 bits each, huh? Bits. So what we can do, I guess we just use an array, huh? So bit count, sure. Bit count array equals. You're wrecked, need to walk my dog. I'll keep your stream up for when I get back. Okay. Well, hope we have a fun walk. In fact, I should be getting some exercise too. Let me switch my standing desk to standing mode. Why not? Okay. Yeah, that feels a little bit better. Not slouching in my chair anymore. No longer being a shrimp. A count array. Okay, so that's gonna be an array. I forgot how you do this. It's kind of funky in Python. I think it's 0. Is it 0 times? Wait. Is it? Is something like this? And if we print bit count array. Okay, what if we change the first index? Yeah, 0 equals 1. What happens now? Okay, no, that works. Exactly what we wanted. Okay. So now we can do this dynamically. This would be the length of the first line. We have to... wait. We don't have to strip the last character, if I'm not mistaken, because those are converted. So, let's see. Length of inputs array 0. And then we should get, was this 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, hold on one. No, I think it does include the last character, yeah? Length. I think that says 13, and this should be 12. Let's see if I count it wrong. No, it's definitely 12. Okay. Let's just do that strip. No, oh yeah, I didn't strip this one. Should match the array now. Should match the array now. There we go. Okay, now that we have this. So here's an array of with length of each number, I guess. The length of number in inputs. Okay. Now, I guess we do the for loop for number in input.text, which would be input array. Number in inputs array. I guess we're just turn this in num. We're counting each bit, right? If I'm not mistaken. Yeah, we're counting the number of ones. So for char in, just remember, we'll use C. For C in the num. Binary? Hold on. Binary num. That didn't do anything. Binary num. You see F2 actually changing for me, but I guess it doesn't do it in replit. That should be fine. Binary num for C and binary num. So this should print out each character. Alright, I guess we can rename this to bits, huh? Each bit. And then I guess we can break after the first run. So is that right? 0 0 1 1 0 0 1 0 0 0 1. We do need to strip the new line off. That's gonna be a little bit of a pain. Should I actually? I might actually do that. It would be something like this. So x for x in, sorry, it would be x.strip. And we don't have to deal with all the stripping. Right. There we go. Okay, now we just gotta test if each one is 1 or not. Ah, wait. Oh, actually, we want to get the index of it. So we're actually gonna take I and range of binary num, or length of binary num. Actually, not. I don't think you can actually do that. Range of binary num. I think it just gives you an error. So print binary num I, and that should give us the exact same thing. Except that printed all of them because we removed the break statement. Okay. Yep, exact same thing. Okay. So now we want to test if binary num I is equal to 1. And then bits counts array I plus equals to 1. And that should be good. And we're just gonna print the bit count array at the end. So we run that, and does that make sense? How many numbers do we have? I guess that makes sense. Around 500, because it's either 0 or 1. If it's random, it should average out to about 0. Okay, yeah, now we need to convert them each to each to a decimal number. Oh, and so we also want the inverse of this, which would be the length of input array gamma rates equals. How do we want to do this? We just need to invert of this. I mean, we could just we could do like we could do it as we go, or we can calculate at the end. Which calculating at the end is actually probably easier. So inverse bits count array equals it'll be x, the length of input array minus length, or it would be minus x for x in bit count array. And then if we print that, it should be the exact opposite. It's a little janky. So we have 1,000 lines. 49 plus 511 is 1,000. Yes. Now we just need to calculate the binary for that. I don't know if I actually want to do this. That should be fine. Binary to. Pretty sure there's a method in Python, a function to do this. Binary to decimal, and we get binary so for x we would start from the right now. Actually, is there a way to do that backwards? We could. There's a few ways to do this. I'm not sure which one's better. I in range of 0 binary num, and we do -1, right? Or it would be the other way. Binary num to 0. Or would it be -1? This would be binary num -1. I think. Start from the back, or work our way to the front, and -1 is exclusive. Yes. Okay. So we're gonna have our total right here, 0. Okay, no, we have a for loop already. So binary num. We're gonna need our power equals 0. So binary num I total. We're gonna add this to the total. Times 2 to the power. Right? Hey, Sickums, thanks for subscribing. 9 months. This seems like it would be easier in C. It might be. The binary stuff, yeah. How do you do exponents again in this? No, this is not right. I feel like this isn't right. Yeah, I was thinking maybe we just like use binary in this. I think Python does have it. but I just haven't touched it before. We'll just do it this at times. It's giving me a caution though. Total equals binary. Oh, plus equals, no. Oh, there we go. Yeah, that's right. And let's add parentheses just to make sure we don't screw it up, and then we return total. So I'm just gonna do a simple test. So our test num would be what's the easy number? 1100 should be what is this? 16 plus 8? 24? No? Wait. Does it? No? Wait. This one's... Is this 8? Wait, I can't remember anymore. Okay, let's start with an easier number. 1 to 0. That's 2. Okay, and then print binary to decimal test num. And let's just comment all this out. Not run. Yeah. Oh, I let's comment everything but our function. That'd be great. Yeah. Binary. Oh, right. Let's int. Oh, power. We never increment power. Right? Oh, that's not the only issue, is it? 23. Binary num. Oh, binary num. It's the length of binary num. What am I doing? One. And then we need to increment power. So power plus equals 1. 2. Okay, let's try this one. 3. This should be 4. Okay, I think we got it. This should be 15, yeah? Alright, there we go. Now we uncomment this. And then we're gonna need, what is it? Gamma rate. Wait, which one switch? Gamma rate is the first number. So it'll be bits count array, right? So gamma rate equals then binary to decimal. Wait, array to... Hold up. We need to make the array a string. So I think it's this. It's join. And then bits count array. And the same thing should be this. It'll just be the invert one. And this is epsilon. Epsilon. So on. Print. What day is this currently? We are on day 3. And then we multiply those two together. Print. Gamma rate. Epsilon. And we print gamma rate times epsilon. Expected string instance found int. Okay, so I got here. Join. There's some nerding out right here. Hey, what do you mean? This is fun. I respect it. Okay, am I doing this wrong? I think it's something with this function here. Let's make sure this is actually doing what we want it to do. I'm gonna count out the rest too, actually. Right. Anyone remember what the number was? Undo. Okay, 489. Wait, what? I forgot. Wait. Eh? What are we doing with this again? I don't remember. Most common bit of the number is... Oh, right. Okay, no. Oh, yeah. No, we're doing it wrong. So rather than doing this, we need to do... Actually, what happens if it's exactly 500? I guess there's no case for that. But what if? What if? We don't know. Yeah, exactly 1,000. So it can be either or. Or it can be 500. What am I doing? What am I doing? Let's actually comment what we're doing. This might help. So iterate through inputs, then count number of ones. Okay, I think this was a little bit of a mistake. What is commenting when you're speedrunning? Well, I'm just chilling, really. If I really wanted to speedrun this, I think I could do a little bit better. So now we need to convert this set of numbers into ones and zeros. So if it's less than 500, it's a 0. If it's more than 500, it's a 1. Man, that's convoluted. So for convert to ones and zeros. I'm just trying to come up with any excuse not to comment my homework code. Always comment. Always comment. Because once you go back, like a week later, you're gonna be like, huh? Wait, what did I write? I tried doing that for like 20,000 lines of code. You're gonna have a hard time with yourself. So let's see. For bit and array, bit counter array, bit count array. We're gonna make a new array for this. So actually, let's make a string. This should make it easier. So this would be gamma string equals an empty string. So for each bit, if bit is greater than or less than 500. Hey, Cyber Depresso, thank you for following. If it's less than 500, then we do gamma string plus equals 0. That would be a string 0. Else elif bit is greater than 500. Gamma string plus equals 1. And then if it's 500, I have no idea what happens. Seriously, what happens if it's 500? They don't actually say. But I guess we assume that we never get that input. But yeah, okay. So let's print a gamma string. If it doesn't break, exit. There we go. Yep, no, don't worry about it. And then we're gonna convert that. I should probably make this into like a function. That's fine. We'll be fine. Yeah, we don't need this anymore. Let's just do gamma rates. And then epsilon rates. We'll worry about that later. Print gamma rate. So let's see if this runs at least. Nope. Expected string instance. Found int. Oh right, did I think I put in the wrong one. It'll be gamma string, yeah? Gamma string. Try it one more time. There we go. That's a number. I'm not sure if that's the right number. We're gonna have to calculate the epsilon string as well, which would be the inverse for this. So I guess we can do it here as well. Epsilon string equals empty. Epsilon string plus equals 1. Epsilon string plus equals 0. And then we just need to convert each of these to epsilon. Why can't I spell? Epsilon. There we go. Rate equals in to decimal epsilon rate. I should move this to the front, actually. As long as it works. Move our functions all the way to the front. Just to clean up a little bit. Convert binary string to integer. Print epsilon. Actually, let's just do it on the same line. And then epsilon. Right equal wait. Something's wrong here. Epsilon. That's why I just ignored this line. I'm spelling it wrong. Epsilon rate. Epsilon string. Then we're gonna print out these two. Oh, wait, I have it right below. Okay, and right. Well, that's a number. I don't think I actually copied that. Okay, right click. And replit. Okay. Hey, first try. Let's go. Alright, part 2. That was only part 1. Part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using the similar process that involves filtering out values until only one remains. Before searching for either rating value, search with just the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Okay, we're just looking at the first bit. Right? Is that what it's saying? Okay, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. What? Okay, if you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process concerning the next bit to the right. The bit criteria depends on which type of rating value you want to find. To find oxygen rating, determine the most common value, 0 or 1, in the current bit position. Okay. And keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 1 in the position being considered. What? Okay, for example. Wait, okay. To find CO2 scrubber ratings, determine the least common value. 0 or 1 in the current position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 0. For 0 in the position being considered. I don't think I'm high enough for this. For example, to determine the oxygen generator rating value, use the same example diagnostic report from above. Start with all 12 numbers and consider only the first bit of each number. Okay, there are more 1 bits, 7 of those, then 0 bits, 5 of those. So keep only the 7 numbers with a 1 in the first position. Oh, okay. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bits, so keep only the 4 numbers with a 0 in the second position. Okay. I'm gonna have to, like, draw this out or something. So... in the third position, 3, 4 numbers. Okay. And then we continue. Let's actually... okay, let's get their test numbers. Just gonna need to write this out. Test. So this is their starting numbers, right? I need more space. And there we go. And then... where are the values at? So they have 1, 0. Actually, here it is. 1, 0, 1, 1, 0. Wait, that doesn't make sense, does it? Oh, wait. Hold on. This is the common values between them, so... Alright, I need to sit down for this, I think. It's a little confusing. Okay, I just want to grab these numbers that they wrote down. So since there are fewer 0 bits than 7 bits, we keep only the 5. Wait. No, this is oxygen. Let's just start with oxygen. This one is the exact opposite, or it's not exactly opposite, I guess. How would you say it? You do it inversely. You switch to 0s and 1s. So for this one, we keep only the 1s. So we're gonna ignore this first number. Keep 1 1 1 1 0 1 0 1 1 0 1 0 1 1 1 1 0 1 0 1 0 1 1 1 0 0 1 1 1 1 1 1 0. No, wait. these ones we throw out. That one we throw out, and we throw out the last one. Okay, so that's the numbers we keep. And then for the next one, it's zeros. So we want to keep this, 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 and this. One zero one zero one. Throw that one out. 0 0 0 0. And throw that one out as well. So we only have the 4. Then we need. We can throw out this last one. We'll just copy this line. Damn it. How do we? Ah. Okay, there we go. Wait, what? Does this make sense? No, wait. That... There are fewer bits. Don't we just... Am I doing this wrong? I feel like I'm doing this wrong. I'm definitely doing this wrong. It shouldn't be the same number, I think. Wait, what? Hold on. Start with 12 numbers. So keep numbers 1 in the first bit. Next one, there are more 0 bits. So we keep only numbers with 0 in the second bit. Third position, 3 of the 4 numbers. Wait. Third position, 3 of the 4 numbers have a 1. What? Wait. Okay, fourth position, there are 2 of the 3 numbers that have a 1. So we end up with this. In the fifth position, there are an equal number of 0s and 1 bits. So to find the oxygen rating, keep the number with 1 in that position. So we end up with this. So, and then there's an equal number of 0s and 1s. Wait, did they actually explain that? Oh, no. Oh, are we just testing each set of numbers? This is funky. Okay. Wait, what? Okay, yeah, so for the first one, we just use this first number that we get from our... I guess we're gonna rewrite it anyways, but we use this first number, right? So there's more 1s than 0s. So we eliminate all the 1s, so we look at this list. And we count the number of 1s in the second column. And there are more 0s. 1, 2, 3, 4. Then there are 1s. So we throw out the 1s in the second column. This is so funky. Then we do it again. This is, there's more 1s in this column. So we throw out this one. And then there's more 1s in the fourth column. Yes. I'm gonna do this. Okay, fourth column. So this lines up with this. Start with 0, and then if they're the same, we add a 1 to the end. Or we just keep 1. We keep the 1s with 1. And we keep going. And going, and going, and going. This is very convoluted, I must say. But I think we can adjust our code a little bit. Maybe I should move them to like their own functions, and then we could we change them accordingly. So this one is parts1.py. Do you subscribe to Nick White on what? Are you just advertising yourself? Please don't do that. That's how you get banned. I was gonna give you money, but now you get none. You can keep your money, dude. But if you're not here to enjoy the stream, then you can leave. Thanks. Yeah, so let's see. I think what we want to do is oh man. Okay, yeah, rather than I think we just make a new function. So count bits. Count bits. Then we're either doing okay, we're start with a string. Not string, the list, the array. What's that a keyword? Yeah, whatever. Array. We're gonna do which column, and then which bit, I think, so that we can reuse this function later. Or is it bit? Does it matter? Actually, no. Rather than bit, does that make sense? I guess maybe inverse. Oh, that's gonna get so complicated. So we have this. We're basically doing the same thing here, except we're just doing the specific column. Yes. Yes. Right through input, count number of ones. So it would just be this. It'd be great if I could just make one function for this. I think I can, kind of. I'm trying to think. This is a little too complicated to just like think out all the steps in my head. Iterate through input for binary number in input. Okay, this would just be array. Okay, we just count them, I guess. So count. That's not how you spell column. Count equals equals 0. And we start off with 0. Count number of ones, I suppose. Or no, we don't count the number of ones. No, we do count number of ones. It's just whatever's greater, we just keep. Okay. Right through inputs. Through array. Counts equals 0. Binary number in array. Yes, and then we do, we check that column. If column hold on. Binary number and then column. So the column number is equal to 1, then we add the count. And then do we just throw them out too? Yeah, we don't really need to count the bits, to be honest. Is it filter? Filter column? That could work. Equal to 1. If we want to inverse it, man, it's getting a little too complicated if we do that. Maybe we can just copy the function and do it later, right? Okay, so we count the number ones in column, and then if count equals or is less than, if it's less than array dot length, yeah. Or length of array. What am I doing? This isn't JavaScript. Length of array. If count is less than length of array, then we throw out the ones, so we can keep the zeros. Do I write another function for that? Maybe. What day and what part are you on? This is day 3, part 2. Maybe we should write that somewhere. Let's add that. Since people keep asking. Day part. Okay. And then day 3, parts 2. I'll put it right here. Right. Actually, how about like random middle? There we go. This is the last one I did. Took me a lot longer than the previous parts. Yeah, this is a lot more complicated. Definitely see that why. Okay. If count is less than length of array, then I'm just gonna write it down. Throw or keep zeros. If counts is greater than length of array, or equals, I guess. Okay, I guess it should be else, yeah. Else, and then we can comment this. Just keep track of that. Keep ones. Keep zeros, keep ones. Okay, I feel like we should just write a function for this. Check and filter, and this can just be filter. So array and column, and then the int, or which bit. So we're gonna iterate through. Our array. So new array equals an empty array. And for I guess I in array, we can do, I guess we can do elements. E. E. For E in array, we will check that column. E column. So if E column is equal to bit, then we will add it to the new array. Dot push? Wait. Append? There we go. Append E. And then we're gonna return the new array. You want people to point things out as you go, or leave you to it? That's a good question. I like to do it myself, I think. But yeah, maybe at the end, if you have some suggestions, that'd be great. Prefer to try it myself first. Yeah, me too. Exactly. Okay, so we're gonna do filtered columns. Filter columns on the array. Or we're gonna return this, right? Array, the column, and then the bit, which is 1. No, this one's 0. And this one would be 1. Does that work? Well, I guess we could try. Check filtered column. That's sure. Hold on. This would be. I guess it'll be. Hold on. Gamma, right? Gamma filter. Gamma filter. Column. Man, this is getting convoluted. If count is less than length of array. Am I doing this right? Yeah, I have no idea what I'm doing anymore. I could probably remove some of this. So... Let's see. Array... We don't really need this either. Anymore. Iterate through inputs, count number of ones. No, we're okay. We're gonna iterate through length of number, length of bits, count, and then we're going to try and return the number. Find a number. So for I in range of, I guess, just the first inputs, which would be inputs array 1. I don't think I need any of these anymore. Maybe. Yeah, no. Okay, you just have these. I'm gonna move these all the way to the front, just to keep it a little bit organized. It's already looking sort of like a mess. I prefer the Visual Studio like highlighting method or color scheme, I guess. So, basically we're starting fresh. Let's not get intimidated by this. And we're gonna have to write the one for epsilon, right? So for I in range Enough inputs. No, input 0. I guess it really doesn't matter. We should try it on a test input first. So let's do that. So for for I in range, okay, this is the bits. Gamma filter columns. So while, dude, can we copy this? Yeah, let's just copy it. So new array equals. Yeah, I don't know. I can't come up with a name for this. New array would be equal to inputs array. I think this makes a copy of it, if I'm not wrong. I could be wrong though. Inputs array. Otherwise, we would have to copy each element, which would be, it wouldn't be too much harder. It would just be this. X for X in input array. Yeah, I don't think we need this. But I could be wrong. Actually, we don't even need to keep the original input, right? Actually, we might. No, we need to do it twice. One for gamma, one for epsilon. So, yeah, we're just gonna do that. So while new array, length of new array. Actually, no, we don't need to do a while loop. That doesn't make sense. But we can do a check at the end, so let's add that now. If new array, actually let's move this outside then, since we're not using a for loop. Or a while loop, we're using a for loop. If new array, if the length of new array is 1, then we found our inputs. Or we found our gamma value, right? Actually, not gamma. What they call it? CO2? Oxygen and CO2. Okay, I need to rename these. CO2. CO2 filter. CO2 filter. No, it's not actually showing up. My autocomplete is equal to 1. Then we can break, and then we can print it. New array 0. And then we're going to filter. Hold on, what happened here? That should be right. And then, yeah, I don't know what's happening here. Undefined. CO2 filter column there. I'm struggling. CO2 filter column, array, column. So new array, and then the column number, which would be I. Yeah. And then that would be the new array. And then we do a check, and let's see if it runs. Oh, we didn't actually copy the original. Let's do that, shall we? Test, not text. There we go. And let's try another run. String object cannot be interpreted as an integer. Which line is this? 40? Oh, length. Forgot about that. Length of... Run. Please work. 0010. That doesn't seem right. Something's not right here. Okay, what happened? column, go to 1, count plus equal to 1. Count the number of ones in the column. Then we, if count is less than length of the array, oh, half. It's half the array. Whoops. Actually, how does that work? I think I need to figure that out. No, I don't think integers really, or floats matter. So if it's, let's say if it's 7, it would be 3.5. So if it's 3, it'll still be less than it. If it's 4, it's greater than it. And it should be fine. So let's try that again. 1, 0, 1, 1, 1. And let's see if that's the value that they got. Yes, it is. Okay, nice. So this is, let's do CO2. O2. I guess let's change the name. CO2. All right. CO2. And I want to make sure that our input didn't change. I don't think it did, but just as a precaution. Okay, we're good. I imagine it wouldn't, but sometimes it gets funky. So now we want to do the same thing with our... Actually, wait, that one's oxygen. God damn it. O2. Let's do oxygen. Oxygen. Oxy? I feel like that's a drug name. We'll be fine, right? So the oxygen array 0. Length of oxygen array. It's not actually autofilling anymore. Not sure what's happening. Maybe I should refresh. Right, print. Yeah, no, the autofill's gone. Oh no. Okay, now we just want to do this with CO2. And I didn't even rename everything. Oxygen. At least it's telling me when it's wrong. Sometimes. I'm just gonna be lazy and copy this. That's probably the easiest way. So we're gonna do CO2 for you. This one's, what is this? CO2, start with all 12 numbers. Consider only the first bits. There are fewer 0 bits, so keep only the 5 numbers with 0 in the first place. The fewer numbers, right? So if it's less than, we keep yeah, we switch these. Okay, I think that's it. And then we just do the same thing for CO2. CO2. I'll just do carbon dioxide. Okay, yeah, that should be fine. So, CO2. CO2. This is where F2 would definitely help a lot. I think I'm gonna refresh the page after it saves, so I can get the autofill back. Actually, I don't think we need it anymore. Run. Oh god, what have I done? Hold on, what have I done? I think I messed something up in the renamings. Oh, this one. Ah, I see. Oxy. This one's CO2. 01010. 01010. Nice. Right, 0101. And we just convert this to decimal. So I'm just gonna hold on. Yeah, oxygen level equals I guess binary, huh? Binary equals oxygen array 0. And we're gonna do the same thing for this one. Just to make it a little bit easier to read. CO2. Oh, CO2 array 0. Yep, okay. And then we're gonna convert those to actual numbers, and then we're gonna multiply them. Wait, what? Use the binary numbers to calculate the oxygen generator rating and CO2, then multiply them together. What is your life support rating of the submarine? Okay. So, oxygen rating. What's the other name? Yeah, that's fine. This is fine. Calculate values. Or I guess convert values would be more accurate. Convert and calculate? Convert. And calculate. Oxygen level binary. Binary to decimal. And then just same thing for the next one. CO2 rating equals CO2 level binary to decimal. I don't know why I'm doing it backwards, but it should work. I'm gonna print those. Please, where's the autocomplete? This is painful. And then print oxygen. You know what? There we go. So much better. Okay, and we run this. 230. Please. Oh, wait, no, that was the original one. This one, the test value? Yeah, there we go. Okay. Now we have to test it with the actual inputs, and that's a big number. But I think that should be right, though. Paste. 40 seconds. Well, I guess we're just gonna chill for 40 seconds. Enjoy the lo-fi. Oh, alright, games ad. Huh. They're really going hard on their advertisements lately. Alright, let's go. 5 seconds left to wait. Damn it. Come on. There we go. Day 3 finished, thankfully. Maybe I should copy on some of the prompts, maybe. Good work. Thank you. Thank you. You said you had a suggestion in mind, right? This was, let's see. Filter column for oxygen. Column for carbon dioxide. And then filter, well, count and filter. Filter column of specific bits. I think there was some logic in your most common method. It didn't take identical amounts into consideration, but I think you must have fixed that. Oh, this part, right? No, this is, wait a second. I mean, it must have worked, I guess. But, if I remember correctly, it said, if it was less than... If there were less ones than zeros, we keep the zeros. If it was more ones than zeros, then we keep the ones. But then this is inclusive, so it would be greater or equal. Which is the inverse of less than. I don't know how that worked out for this one. I guess it has the same idea. I guess it just made it easier on us. I mean, I guess we could just do this, and then that would have fixed it. If we had to change it. I don't know. It worked itself out. I'm not gonna question it. If it works, it works. All right, on to day 4. This is taking a lot longer than I was hoping for, but that's okay. Day 4, giant squid. You're already almost 1.5 kilomiles, almost a mile below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Okay. Numbers may not appear on all boards. If all numbers in any row or column of a board are marked, that board wins. Diagonals don't count. Okay, we're not doing diagonals in this one, huh? The submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. It automatically generates a random order in which to draw numbers and a random set of boards. Interesting. I went a weird route with that at first. I had a most common bit method, and then I was inverting it. But when I added the logic for bits, it really screwed up. I'm gonna drop it now because you're ahead of me. Good luck. Okay, thank you, man. Have a good night. But yeah, that's kind of exactly why I just didn't bother, like rewriting this function. Instead, I just had to change a little bit, copy and paste it. Wait, copy and paste it, and then change these bits, and yeah, it worked out. It's a lot easier. It is a little bit more redundant though, so it's fine. I'm not gonna try and be the most efficient, but I at least want to be like happy with what I write. This is fairly. This is fine. This is fine. Submarine has a bingo subsystem to help passengers. You giant squid. I'm playing against a giant squid? Is that right? Maybe it wants to play bingo. Okay. For example, 7, 4, 9, 5, 11, 17, 23, 2, 0, 14, 21, 24, 10, 16, 13, 6, 15, 25, 12, 22, 18, 28, 19, 3, 26, 1. Whew, okay. And then these are the cards. Or the boards, I suppose. I wonder how my input looks like. Alright, that makes sense. At this point, the third board wins because it has a... Oh, wait, what? So these are first 5 numbers if there are no winners, but the board are marked as followed. Shown here adjacent to each other to save space. Are these bolded? Yes, they are. I can't really see it that well, to be honest. But I think it's this one, this one, this one, this one, this one. Yeah. If the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn, and we have this. At this point, the third board wins because it has at least one complete row or column of marked numbers. In this case, the entire top row is marked 14, 21, 17, 24, and 4. The score of the winning board can now be calculated, starting by finding the sum of all unmarked numbers on that board. Is that how you calculate it in bingo? I don't know. I haven't really played, like, real bingo. In, like, classrooms and stuff. Let's see. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on the board. In this case, the sum is 188. You know, it might be just some weird thing that they did. That for this challenge. Then multiply the sum by the number that was just called when the board won 24 to get the final score. Or maybe that's some sort of strategy. Maybe you have another 4 in a row, but you already had one complete. I don't know. It's risky. To guarantee victory against the giant squid, figure out which board will win first. What will your final score be if you choose that board? Oh, so we're giving it a board, but we're going to be cheating. We are cheating. I think the giant squid's not going to be happy when it finds out. Okay, let's rename this to parts 2. We are done with that. I feel like I should rewrite some of this, but this is okay. I should add some more comments though. Yeah, we're done with this. Let's move on to the next. Do I need... I don't think we need anything. We'll just rewrite it. It's fine. Inputs.text. That's our inputs. That's our boards. We have so many boards. Oh my god. Oh no. Alright then. So, let's see. With open. And then file name, right? File name equals inputs. Single quotes. Gotta follow the conventions. Inputs file name. Read as f. Inputs equals f dot read lines. Okay. Or in what did I name it last time? Input. Actually, what did I name it? 3. Input array. My eyes. Just trying to keep it consistent. Okay, now. We should get these bingo numbers. So call numbers equals input array 0. Inputs array 0 dot split, and we split by commas, if I'm not mistaken. And then let's print the call numbers. Okay, wait. You. Let's delimit you. Dot strip. Or strip, I guess. Yeah, let's get rid of you. Okay, much better. So now we want the inputs, the boards. Boards equal, we're just gonna make a bunch of arrays for each of them. Numbers called. Okay, that's a little a little strange. Boards. So for... I feel like we should just get rid of the first 2 lines, honestly, in input, but that's sort of... We sort of don't want to touch this input array. How do we do this? I guess we can start with the 3rd line, which would be line 2. For... Okay, let's make a board array. Boards. So we're gonna have an array of boards that has boards which are arrays. So this is gonna be a 3D array, isn't it? Oh, that's gonna be a... Oh no. Just thinking if there's a better way to do this. It's not too bad. I think the board's only a 5x5, so we'll see. Actually, maybe we should convert these to... we don't need the strip, I don't think. We just convert them to ints. So x int x for x in that. Wait, missing something. Int x for x in input. All right, there we go. And then I'm just gonna comment this out. Print column numbers. Just make sure it's still sane before I lose my sanity. Okay. Yep, those are stripping for us. Don't take that out of context. Boards. Okay, this is 3D array. This might be a little strange. We could just do the first board, I guess. And then we can expand it from there. That might make it a little bit more complicated though. I don't think we want to do that. So we're gonna iterate through our inputs. Inputs and append new boards as we find them. I'm not gonna add that last part. For line in inputs array, I wonder if we can... I mean, I guess we can do this. This is gonna be a little strange to... Line start. Or board start? Board start equal to line 3. And then current line. This is kind of stupid. Actually, why don't we do this? If this is so stupid, why am I doing this? If board starts greater than 0, continue. And before the continue, we do board starts minus equals 1. So this will skip the first 3 lines, which I think we want first 2 lines. We want to skip the first 2 lines. And then I just want to print the line. God, this is stupid. I mean, is it stupid if it works? Let's break up the first line though. Okay, yeah, that is, I think that's the first line. Yep. I think it's just easier like this, no? Sure. Skip first lines. Board line starts board. Or start line? Start line? Makes sense either way. This one, I don't know. This follows English better. What am I saying? Anyways, so we're gonna make a new board. So temp board equals just an empty array. Yes. Yes, okay. So this is just gonna be like, this one's gonna be dimensional. It's just gonna go straight down. So board 1 would be 1, index 0, board 2 would be index 1, board 3, okay, yeah. And this one's gonna contain each set, which would be like this. So this one would be its own array, this one would be the second, third, yep. I think that makes sense to me. Where am I going? Main. Okay, and then, yeah, so if, let's do if line, do we want to use regex? I'm gonna try and avoid regex. I think we should be fine. If line.strip, right, is it's equal to an empty array or empty string, then we're just going to make a new temp board, and we're gonna append our current board and make a temp board, new temp board. So board dot append temp board. I guess I can rename it new board. New board. What's happening here? Boards. Boards. There we go. Okay. So append board and make new board. So LF. Actually, no, we don't do an LF. We just add this to the board. Board. New board. Dot append. We're gonna add an array, and then it'll be x int x or x in line. So yeah, we're just gonna convert them to ints and then append that array into the new board. And then how about the last line? What happens with the last line? Oops, let me close A3. We don't need that anymore. Just gonna confuse me more and more. Yeah, so, and then for the last, I guess for the last line, we just append this to the last new board. Yeah, let's do this. Equals empty. And I think that should be fine. Print boards. Invalid literal for int with base 10. What is that? Int x for x in line. Oh wait, did I... Right, I need to delimit them, right? With spaces. So it would be int x for x in... for line... Wait, what? For x in line dot split. And then that should be fine, I think. And then we just want to look at this first one. So print boards 0. I should clear this. That's not very pretty, is it? Let's see if we can adjust this so that it looks a little bit better. Ah, there's like that one line at the top that's been cut off. It's not gonna be padded correctly, but this gives us a general idea, I think. You know, let's for this is a little. I think this is a little too much just to be printing things, so. Print line. And this should give us our board. There we go. Much better. Maybe you should do it for... Okay, let's make sure that lines up. Yes. And then let's do it for the last board. Okay. Then you could. Wait, what? What is that? New board equals... Oh, we need to continue. Otherwise, yeah, we get the extra line. We don't actually break out of it. Okay. So that makes more sense. Make sure that works for the other lines too. I imagine it does. 30. It's the second one, yeah. And wait, I actually didn't check for this. But I think it's good to go. Final append. Or append final board. So this is just printing. We don't need that anymore. Okay, now what are we doing with this? We are checking each board, right? What can we do? It's vertical and horizontal, yeah. Row or column. Okay, that does make it easier though. So I guess we can do a check board function. Find check board. Yeah, that'll work. Check board. So we get the board, which was be an array, board array. And then we get... Actually, we can do this. List. What are these called again? I think they're like suggestions or something. I forgot their official name. But board list. And then we're gonna do... I think that's it, yeah? Would it be better to just check every board? Okay, yeah, there's multiple ways to do this. So what we could do is, say we have this board, right? If we find a number, or the number comes up, we can just remove it from... Or we can replace that number with like a... I guess like -1, because -1's never gonna show up. I think 0 does show up, right? Yeah, 0. So -1 could be like a marker for that slot taken up. And we can check each line, we can check each row to see if they are complete. The other way, okay. No, well, we have to do it like that. But I was thinking, rather than we go through, we look at the number, call numbers, right? So instead of iterating through each call number, entering each call number. So, and then checking the board if they're finished. We look at each board and then we see how long it takes for them to finish or get their first bingo. That might be a lot faster because we don't have to go here, check all of them, go back, check all of them again, and then keep going, you know? Oops. Yeah, I think that'll be the way to do it. Checkboard. Okay, how are we gonna do this? So it's gonna be a square. So for check, let's do check rows, and this one will be check columns. So check rows is gonna be a lot easier because we just check for I in actually we go line by line. Actually don't know the easiest way to do this. Never really come across this like type of problem. They're usually like little test questions. But yeah, let's just do it the easiest way. For I in board, should we do that? I think we should, right? For I in board, so this would be each row, and we're gonna check the column of the row. Man. Okay. So I'm gonna do it like I said. I'm gonna mark them as -1 if they're taken. We can also just make like another board on the side, and then just fill them. Like they can just be nulls or something. Actually, nulls would work too. Null? I think -1 is a little bit nicer because it keeps the formatting with 2 decimal. Yeah, these little 1 decimal numbers are really throwing it off. So if I in board, or for I in board, if I equals okay, we can do number drawn? Numbers marked? Numbers marked. Sure, marked. Equals 0. So if for I in board, then we do the column for I guess J in board, or in I, J and I. If marked equals, we're gonna do an if statement here. This equals 1. If J equals did I pen them right? Yeah, int, they're all ints. Okay. If J equals I guess -1, then we're gonna mark num marked equals +1. And when we go to the next line, if num marked equals 5, I guess it'll be the however long board is. So equals length of board equals. Then we what do we do? Return bingo? Return 1. So that's oh, that's not finished yet. Num marked equals 0. And then it'll go back to the next, it'll go to the next line and do it again and again and again. So this one we're gonna have to do something similar. So what's gonna end up happening is, oh yeah, and then we return, actually no, we don't return yet. We return at the end, just in case nothing, false. Cool. Return false. Or no, this one would be true. Yeah. Whoops. So this is similar. We can't do it like this though. It would be range. We would have to do range. Range of board. Length of board. What's range of board actually do? I don't think it, yeah, I think we ran into that problem. It just doesn't work. So for I in range of length of board, J in range of I, well, it would just be the same thing, but yeah. And then if we need to check J. So J would be this, which the columns, or the row number, I guess. So if board JI, man, this is gonna be weird. Let's go to -1. The marked equals, okay, and I think that should be fine. So I'm just gonna, I'm gonna do a quick check. We're gonna run this through a temporary board. So all this can go for now. Just come back when we need you. Let's do, just copy this. How are we gonna do this? Temp or test board equals what? Right, you can't copy it straight from the console. And do paste. I think this should just work like that. And we need commas. That is all. Print test board. Make sure our test board is valid. I think that's valid. 1, 2, 3, 4, 5. Okay. Now we're gonna run checkboard on this. So we're gonna make these -1. All of these. I'm not gonna test every case, but I'm just gonna test a few of them. Check board on test board. Run. False. Goddamn. What have we done? done. False. So I did get to this end. Range of length of board. Ji equals -1. So what's happening here? Let's print. Let's see if it's actually getting the right numbers that we want. Okay. Wait, what? Hold on. These -1s aren't getting picked up. It's going 50, 34, 84, 16. What is happening here? 16, 33, 41. Wait, oh no. Wait, okay. Let's look at this one. 58, 34. 8, huh? Wait, how did that happen? Range of I. I don't think I have to do 0 to length of board. Oh no, it's not 0 to I. It's 0 of J board I. Okay, that should make more sense. I knew I mixed something up there. Okay. Length of board I guess. Actually, it doesn't matter. They're all squares. Let's just do that. Okay, so we got through that one. What was our? Anyone remember? Let's just add random numbers. Shouldn't really matter. 12, 1, 21. And then let's do here. Let's do -1s. True. Okay. And then we're gonna do this line instead. -1. -1. This is assuming our boards are correct, which they are, but our program doesn't know that. True. Oh, yeah, it's not printing because we're in the first one. Okay, so that seems to work. If it doesn't, then everything we do after this is just not gonna work. Okay, check. So now that we have a working check, pen final board, then we're gonna iterate through each board. Iterate through each board. Find how long to how many numbers must be called. Finish board. Or to bingo. To get bingo. Blocking error. Yeah, definitely. Okay, so for board in boards. Right. Yeah, that's Okay, then we're gonna do if board. No. We have the call numbers. So for line in board, for column, For each board, we're gonna do... Oh god, this is gonna be a little strange, huh? I guess it would just be... check board bingo, and then we're gonna have mark board, define mark board. So it's gonna be pretty similar. There's a lot of looping in this. Don't know if this is the best way to do it, but this is one way. Board and board, and we're gonna do a number called number. Called num. Literally, it's called num. Okay. For I and board, for j and I, if j equals called num, then we are going to what are we doing? Called j equals called num. I hope that works. And then we're just going to return our board. Actually, we should make a new board, huh? New board equals board. So in our new board, for new board, return new board. Else we return none? Null? None? So, okay, this would distinguish between if it actually got one or not. I don't know if that's exactly what we want. It might make it easier if we just return new board anyway. I don't think it really matters. Yeah, let's just do this. So this is just to return it early if we get the marked board, since each board should only have one number, one instance per number. 0 or 1, yeah, okay. And then I should really check if mark board is doing what it wants, or what we want it to do, so we're gonna have to do another another one of these. Okay, so let's just grab this. Board, test board equals, wish I saved the last one. Oh no, this might take a while. Oh god, what have I done? This, and then add the commas. Maybe I should like put this away somewhere. You know, how about we just not erase it? That'll be smart, right? And there. No, actually that's too many. One too many. So mark board. Let's board equals test board. I feel like we should just do it as null or none, just so that we know that if it didn't return anything, then we don't have to check it again. So that should reduce the number of calls we have to make. This might take a little bit of time to run. I hope not. We might be sitting here for a little bit. New board, return new board, mark board, board. Test board equals, okay. Test board, we mark board. I'm just gonna do this for the sake of testing. Test board. Mark. Who's Mark? Word. Called. And let's do 3. And then we're going to print our... We're gonna do the for loop, huh? Okay, how about we just make a new function? New function. Print. Define. Print board. Man. And it's not gonna have any return. Null. None, I guess. For line in, or for row, I guess. Where did I write line? I think it was down here. Yeah, wait, no? Oh yeah, here. Okay, we can, just one line. We'll be fine. Row in board. Print row. And that should be that. So now we print board and end board. Let's see if that updated what we wanted to. It did not. Okay, I think we're gonna need to do a little bit to this. Length of board, and then we're gonna do range. And then we're gonna do, I guess we're just gonna copy this. It makes a little bit more sense if we do it the other way. If we do length of new board I, but they're all squares, so I'm not too concerned. If we had like a 4x5, then I'd be pretty concerned now. But we're gonna cheap out. If j equals called num, or I guess this would be new board ij. New board ij equals called num. The new board ij is now equal to, wait, why did I, oh, maybe I messed up. Hold up. -1. So I'm gonna copy that for now. And I'm gonna undo. See if I messed up. Equals -1. Nope, okay. Now, yeah, I mean, I did mess up, but not in the way I wanted to. Or expected to. Okay, now we're fine with this. You can go away now. So we're gonna go row, for row in board, for column in row, for column in row. Actually, what am I doing with this? Or, no, we don't need to do this. Yeah, we're gonna make a new, like yeah, number of calls. And this will correspond to the board. Should equal be to 0 times length boards. So for number of calls, or actually, what is it? No. Call nums? Call nums. For number in call nums. Huh? Actually write numbers. What am I? Running out the whole word. No, we don't do that here. For num in call numbers, then we're gonna do mark board and then that number on that board. Num inside. So it'll be board equals mark board. I guess it'd be easier to do this. Yeah. So I in IO in range of the length of call numbers. And we do call numbers I found day 4 super annoying, kept returning to it over and over. Watching someone else do it is therapy of a kind, I'm sure. Maybe. I'm finding it pretty simple so far. I don't know about part 2, but this seems to be okay for now. We're just hold on. We're just looking for the final score. Okay, yeah. Let's find the right board. So for I in range of length. Okay, and then call numbers I. So we try and mark the board. And then do we want to reduce the number of calls? This would just return none then. So we're gonna do a temp board. If temp board equals to, or is not null, I guess, not none. Then we're going to board equal temp board, and then let's see what we're doing. Checking board. We're checking the board. Or I guess for the first 5 numbers, or first 4 numbers, we can skip. We just have to mark them all. So I might do that instead, just so that we don't have to check every board again for the first 4. That should reduce calls even further. So check. I'm gonna mark board for I in range. Actually, we're just gonna do call nums because we don't actually need the index anymore. Compile. Call nums. No, other way. For a number in call nums. Wait a second. No, I guess we do need it since we don't know when to stop. Unless we do count it. Nah. Okay, we'll just copy this one. Length of, I guess 0 to 5? 0 to 4. And this one would be 5 to length. So we're just gonna do temp board. Same thing here, temp board. If not none, and we append it, and then checkboard. Now we checkboard. If checkboard on our current board. Checkboard, yeah. What up? This is throwing me off. I forgot to camel case it. This doesn't even look like a word anymore. I was like, temperword? I'm fairly new to Python, so it's nice to see usage that I can follow with the Advent challenge. Yeah, it's that's actually how I learned Python. I started with the 2018 Advent calendar, and I decided, yeah, I should probably just learn this at some point. Yeah, I ended up finding it pretty easy to work with. I like how well, it's just easier to get started, you know? You don't have to worry about what was it? Like all that all that fluff in like Java and C and stuff. Okay, if checkboard, so that means the board passed. Let's do that. Is valid, or yeah, certainly lightweight. Checkboard. I guess check. Found bingo. So what are we doing with this? Oh, we're number of calls, and then I guess it would be. Oh no, I don't think I I didn't account for that. Oh no. Okay. Well. Okay, this isn't even starting to like a word anymore. Okay, let's do. I guess we rename this J. And we can use I for the boards. J. Yeah. Okay. And would this one be I? No, this one's I. Oh god. It's getting a little bit complicated. Length of boards. And then this one would be boards I. Same thing here. Boards I. And then boards I would equal to temp board. Same thing here. And then we check boards I. So then we mark down number of calls into here. This would be none, huh? Doesn't really matter. 0 doesn't make sense. None doesn't make sense either. I guess none would be like, oh, we haven't reached that value yet. So now we can break out of this for loop. Since we found it, we can break out of this for loop, and then we can go to the next loop. So let's test it for the first value. Let's just break out of after the first board. See if we actually get a number. And num print calls and 0. I hope that works. Int has no length. 82. Oh. 82. Int object is not iterable. Length of... Oh, it's range. Nah. I always forget these little things. Always humbles me. None! Oh, right. A equals I. A equals J? Equals J, I think. 66. What's printing? What's printing all this? Hold on. Find print. Import. No, that's not it. This one? I think it's this one. Okay, 66. Let's actually make the test input. And so we have, it was the third board, right? Oh god. No, we should be fine. Here. And then their inputs was this. Right now, the inputs. Test text 11. Is that right? After 11 numbers, is that right? Oh no, we don't really care, do we? We're just finding the... Wait. No. We're seeing which one will win first, right? Okay, let's just see if that's the right number. So after the first 5 numbers are drawn, after the next 6 numbers are drawn, there are still no winners. After 24. Finally 24. So that's 1, 2, 3... Oh, wait. It's... Oh, I see. Number of calls is J plus 1. I forgot we don't start with 0. We count it. Okay, that should make sense. There should be 12. So 5. Let me make sure. 21 and then 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wait, what am I? 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there we go. Now we've got it. Okay, so yeah, we're just seeing which one wins first and then what the final score will be of that board. We might have to duplicate that board, huh? Okay, the score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on the board. In this case, the sum is 188. Then multiply the sum with the number that was just called. Okay, we don't actually need to save it. So with that in mind, we can remove the break statement. So we have... Yeah, okay. No, we're fine. Now for each board, we gotta get the score. And... let's make a new array. Score? Scores equals... And we'll just do the same thing here. Okay, so we're adding up everything that isn't a -1. So I guess we can just do like a... Define calc score board. I'll just copy the rest of this, and then whatever the last called number was, so that should be fine. Our output will be... Wait, it's not a boolean. What am I doing? Let's do new board. Actually, an array. It's a list. And this one would be an int. Okay, so we're gonna score. Actually, total... Subtotal? Sure. I guess that'll work. Equal to 0. And then we're gonna do a loop just like this, I guess. And then we're just gonna add it if it's not -1. So if it's this, if it's not equal to -1, then we're gonna add it to subtotal. Subtotal plus equals the thing. And then we're going to just multiply it by that number, right? multiply the sum by that number. Okay. Actually, wait. Unmarked number. Yes, okay. Yep. And then return subtotal times called number. And that should be that. So then scores equal scores I equal to calculate score for boards I and the last called number, which would be called numbers J. Yeah. There might be a scenario where it actually never returns. Like, it never bingos. We never get a bingo? Is that a thing? Hold on, let me see. How many numbers do we have? I guess we can just count the number of these. Where is call numbers? Okay, and then do a print length of call numbers. Let's just do this old check. 27? Is that right? Oh wait, no, we're on test. Hundreds. Okay, so that's 0 to 100, yeah? Is there 100 in here? Oh, it's 0 to 99. Okay, yeah, that's 100 numbers. And 0. Yep. Wait. Just 0, space 0. Okay, there we go. So there are 100 numbers. That means every single one will eventually bingo. I guess, wait. You don't need all numbers, but yeah, that makes sense. It's still bingo. It has to be above a certain threshold, and I really don't want to calculate that right now. And I don't need to. So we calculate the scores, add score. And then we're going to do whatever's the lowest, whatever hits bingo first, and then we calculate the score, or we get the score of that. Yeah, we get the score of that board. Okay. So yeah, we're gonna do board number. Okay, fastest board number equals. I think you can do this. Num of calls. Oh, we're not getting any more suggestions anymore. Oh no. And then dot lowest. Yes. And then we're gonna do fastest board index. Hello, welcome. Equals. So we're gonna get index of, or it'll be number of calls, index of. Reading snake charmer. Wait, do people actually call themselves that? That's interesting. And we're gonna get fastest board number. Right, index of? Is that? Is it just index of? I don't remember. It's not giving me any suggestions. Here, let me refresh. Maybe I'll get my suggestions back. Oh, and lowest does not exist. FYI, you want to min. Oh, I couldn't remember which one it used. It's min. Where's our suggestions? Okay, what is index of? I don't remember what it is in Python. Index, it's just index. Oh wait, it's a global function, not a method. So it's min of this? Like this? And index. Yeah. I don't know why it's giving me an error though. Number of call. Oh, maybe I'm missing. Yeah, I'm missing an S. Whoops. There we go. Okay, and then we want the score of that. So score equals scores, and then fastest index. Oh, that's not how you do it. It's index. It's F12 key by accident. Okay. And let's print score. And let's just pray. Let's see if it works. Well, that's a number. Let's see it. Paste. And submit. That is not the right answer. Oh, crap. Okay, something went wrong. Web IDs, to my knowledge, don't put a lot of work into building autocomplete databases like client-side IDs do. Yeah. I find that too. Okay, tried with sample. I should probably test the sample. Okay, let's try it. Run. 4776. That doesn't sound right. Am I... Is it this? Wait. Call... I think this might be the wrong number or something. Ever try using VS Code within GitHub? No, actually I haven't. It seems cool, but I don't know if I'll ever use it really. I guess it could be like a replacement for this, no? What is wrong here? So we did get the right number of yeah, this number of calls. This was right. I need to check. J plus 1. Yes. Call numbers. This might be wrong though. It shouldn't be though, since we break out of it. I guess we can just print that. Print J. I guess we can print this. $24. Wait a second. That makes sense. Shouldn't this iterate through all the boards? I feel like something's wrong here. Length of boards. Yeah, this should print through all of them, not just this one. Length of boards. Oh, am I... Length of boards. Okay, we append the final board. We make these temporary arrays. Or I guess arrays. And then... That's very strange. Did it ever break somewhere? Wait, does it break out of every loop? No, that doesn't make sense. It wouldn't print this then. Huh? What number are we supposed to get? 188 would be the sum. So calculate score. Okay, let's print the sum, I guess. It might be this. Actually, how do we... Okay, what number is this? Let me get the calculator out. This is surprisingly common. Just breaking out the calculator. 24, 199. I'm getting 199 instead of 188. So what is happening? It has to do with my checkboard. No, it has to do with my calculate score, I think. I'm adding 11 extra to the list. I'm still not understanding why it's printing once right here. Unless... Oh, I only calculated once. Oh, right. I mean, I only added the one board. That makes sense. Okay, so... Calculate. Should I just... Okay, let's print the board. Actually, I have a method for that one. Board. And... Okay, is that... Match? Wait, that doesn't match. That extra 11. Where's that coming from? Huh? Where's that 11 coming from? Did I skip one? Oh, I see. This is 0 to 5. Naruhodo ne. So that should be right. I need to get rid of this. I don't need you anymore. Okay. There we go. Change one thing. Answer's completely different. Okay, now we should be able to just comment that out, and... There we go. Copy. Paste. And... What have I done? No! It's still too high. Huh? Eh? Well, these are all right. The bingos are right. Is the index wrong? I have no idea. Maybe I should manually check them. Let's check the last one. Yeah, let's check the last one. Okay. So, break out the calculator again. 50 plus 16 plus 75 plus 88 plus 84 plus 64 plus 31 plus 94 plus 70 plus 39 66 677. I guess we can't really tell the score, can't we? Is this the last one? All numbers. Yeah, this is the last one. What's happening? Wait, where's that? Where's this print statement? Print. Pint. Print. Print board, print row. Okay, print. No, I removed the print board. Okay, there's this one. Where's the other print? Where's that coming from? This one? Oh, that comes from calculate score, right? Print and calculate score. So it'll be 8 times that. I guess we can print the calc score too. I'm not sure what it is. And this will be times 8. 5, 4, 16. Wait, what? For the last one, at least. Int object is not iterable. Oh. Print. Oops. Print. So 5, 4, 16. That is exactly what I got. For that last one, at least. Am I... Okay, let's actually put in the entire input, I guess. Instead of that, just one. And let's change that to test. Five 45 12. Yeah. Huh? Oh god. Why the 2 for 4 loops? Oh, this one? It's just so that I don't have to check again. Or check, I don't have to check for the first 5 numbers. Because, actually, wait, that might be wrong then. 4? No. 0 to 4. Wait a second. Yeah, that might be wrong. Oh. I might have put the wrong numbers. So this would be 4 calls, and on the 5th one, we check. Maybe I should explain that again. So yeah, we're not gonna have a bingo on the first 4 numbers, because that's not possible, I guess. I guess we should do, length of board. -1. The board. -1. Okay, let's try that. Okay, maybe that's it. That might be it. I need to change this to the actual inputs. I think that's it, actually. Less than, not supported. Between instance of none and none type. Nice. What? Oh, what happened here? They're all -1s. Oh, it's minus of board's I. Board's I. That should make more sense. There we go. Let's try it again. Okay, now we got it. Paste. God damn it. 55798. I have no idea. Temp boards. Yeah, the weird thing is it does work for the test input. It's just that scaling it up doesn't. Maybe I just... Here, maybe... I don't think this is gonna change anything. Do all boards never have repeats? I believe they don't. Like repeating numbers? They might. Okay, let's just try that. 55798. That's still the same thing. Okay, we can try that too. Let's see, mark board. And instead of this... Oh god. So we're gonna comment this out. We're gonna return new board regardless. And Welsh Trill, thank you for following. Hit return new board. So where is it? Here? So we're always gonna update it. Okay, that's fine. 55798. Yes, exactly the same thing. Huh? Do I have the wrong input? That might be it. I don't think I do. Here, let's go back to input. Copy. Okay, I'm lost. I'm actually confused. The score of the winning board can now be calculated. Started by finding all the sums of unmarked boards. The sum is 188. Let's, okay. No, it solved that already. I've tried that already. Multiply the sum by the number that was just called when the board won. 24. What will your final score be if you choose that board? Huh? Oh my god, okay, pain. And then, wait, let's see. Well, I think I can put this back. Where is it? Actually, where is it? Yeah, right here. Return none. I don't think this matters. So what is it? 5, 4, 12. Or 4, 5, 12. Which board will win first, right? So whichever has the least number of calls, then that one wins first, right? Am I just not... Should I just try all the scores? That's gonna take a while, I think. Index of fastest board num. Should we print these out? Maybe get some insights. I think calculate score is right. Number of calls, index. We're getting the index of fastest board num. I really don't know. This is gonna haunt me forever. Calc score. So, this prints. Let's remove all these prints. So, we should just end up with the one. What are these? 16, 13, 24. Oh, it's just this. Okay. So, we're gonna print the boards here. Board. It's gonna be boards I, and then we print the boards. We print the boards. This is when they find the bingo. Print the call numbers, and then we print the calculated score. And then let's just add another print on it. Just to format it a little bit better. What the heck? Oh. Yeah, let's actually print it correctly. Forgot about that. Print boards. Print board. Okay. Now, do these make sense? Calculator. So this is a bingo. That's a bingo, right in that center column. And this is a bingo. It takes 16 for that, 13 for this, 24 for this. Wait, what? There's no way this is 13, right? Wait. Wait. Number scores, call number. Okay, and then let's do call for J. Plus 1. So that should be when they find their bingo. So this is 12 on the 15th number, and then this is 14. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's right. So the 14th number is... Okay, wait, let's see. 12th number is 24. I think we got that. 14th number is 16. 15th number is 13. And then I have to add these all by hand. Okay, 22 plus 13 plus 8 plus 6 plus 3 plus 18 plus 1 plus 12 plus 20 plus 15 plus 19 times 16. Okay. Oh. Wait, what? Is that right? Huh? That number does not make sense. Okay. I think I found the flaw? Calculate score. Call numbers J. What is it? Huh? Hold up. Calculate score. What? How is it getting these numbers? Okay, let's do print statements. Debugging. This is great. Start calc. And we're gonna end calc at the end here. And we're gonna print each number. Print. Well, if it's not -1, I guess. Print. Okay. So let's clear this. Running one more time. 14. Eh? Wait, what? 14? Huh? 14? Where are you getting 14 from? Oh, wait. I found it. I found it. It's not new board, it's board. I don't... Ah, there we go. Well, that's what I get for copying and pasting. At least my own code. Yep, that should do it. Run. So what did I get for that first number? 2192. Yep, that's exactly right. Well, that took a bit. Took a bit to find. But we did it. And then I can remove other print statements right here. And let's remove you. Ah, there we go. That looks right. And that was only the first part. Let's go! Okay. I can't believe that. I can't believe that. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting his arms, the safe thing is to figure out which board will win last and choose that one. That way, no matter which board is picked, it will win for sure. Will win last? Okay. In the above example, the second board is the last to win, which happens after 13 is eventually called, and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148, for a final score of 148 times 13, which is 1924. Do I still have those numbers? I don't think I do. That's fine. Figure out which board will win last. Once it wins, what would its final score be? Wouldn't we want to calculate the score instead? And, you know, get those scores? Does it not matter? This is some weird bingo. Okay, well, let's rename this to parts 1. We're gonna make a new main.py. Eh. Okay, we're good. Thought I just died. There goes my progress. Okay, so, well, since we calculated everything, should be fine. We just look for which one wins last, so max. Number of calls. Index of, I guess we can rename this slowest board. Slowest. Board index. Slowest. And then slowest. And we should be good. Also, where's the extra prints coming from? Ah, damn it. I clicked paste by instead. Paste. Well, that was easy. The headache. The headache I got from the first part, and then the second part. Oh my god. Just so... bless. Bless. I have nothing else to say. Just bless. Let's remove all these extra bits. I gotta do it for the first part as well. Rent. Seems to be working. That's the right number, right? Yep, okay. And then same thing for this. Print. And then let's rename this to part 2. I guess I should have changed this. There we go. You get it. Right here. Yep, and now we're on to day 5. I imagine this might take a little bit longer. By a little bit, I mean it might I might not even finish it today. Alright. Let's see. Hydrothermal venture. To come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large, opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents for your puzzle input for you to review. For example, 0959. Wait, what? Oh, I see. So everything from 0 to 9 to 5 to 59 is a vent. Hydrothermal vent. Okay. So they can be diagonal as well, it looks like. 8 to 0 to 8 0 to 0 to 8. Yes, okay. 9 4 to 3 4. So that one's horizontal as well. This one's vertical. 2 2 2 1. Gotcha. Each line of vents is given as a line segment in the form of x1, y1, x2, y2, where x1 and y1 are coordinates of one end. Okay, yeah, gotcha. Now just keep reading, whatever. The coordinates of one end of the line segment and x2 and y2 are the coordinates of the other end. These line segments include the points at both ends. In other words, an entry like 1 1 to 1 3 covers points 1 1, 1 2, and 1 3. Entry like 9 7 to 7 7 covers points 9 7, 8 7, and 7 7. For now, only consider horizontal and vertical lines. Lines where either x1 equals x2 or y1 equals y2. We're gonna have to do that for part 2, aren't we? Horizontals? So the horizontal and vertical lines from the above list would produce this the following diagram. The diagram, the top left corner is 0 0, and the bottom right corner is 9 9. Each position is shown as the number of lines, which covers the point. Each position is shown as the number of lines which cover the point, or dot, if no line covers that point. Okay, I see. If they overlap, you increase it by 1. I guess this is where Python comes in handy? Try doing this and see. It might be a little, yeah. The top left pair is a pair of ones. I guess, instead of you just do ints, right? So if it's 0, you just print a dot. But yeah, this just skips that step. The top left pair of 1s, for example, comes from 2, 2, 2, 1. The very bottom row is formed by the overlapping lines 0, 9, 5, 9, 0, 9 to 2, 9. 0, 9 to 5, 9. This, and then 0, 9 to 2, 9. Yep, okay. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, there is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. How many points do at least 2 lines overlap? Okay, let's get the inputs, shall we? Let's move on to day 5. I'm just gonna hope that saves, because... well, whatever. We already did it. Doesn't matter too much, I suppose. I like to keep a record. Our old code. Code? How can I speak? So we're gonna do just the same with open, and then we're gonna do a file name. Honestly, this doesn't matter too much, but I'll try and make it modular as much as we can. I think there's a little inconsistencies with like length in the last one, but I'm not too fussed about that. Just want to finish as much as we can. Okay, so I'm gonna grab this test input. Test. Text. And then we're just gonna shove that in. There. Let's see. Inputs array equals f dot read lines. Yeah. Okay. A little strange. So now we make an array. We don't exactly know how big the array is gonna be though. I guess we can guess. Oh, that is huge. Oh, interesting. Yeah, thanks Google Translate. Yeah, these are huge. I don't think it goes past 1,000, so we might be safe there. Can I control find? Is there a regex? There isn't, is there? Okay, fine. I think 0 to 1,000 should be fine. Oh, that was... I came out of nowhere. I thought that was something in my house. That's from the Lofi. But yeah, 0 to 1,000 seems safe. I mean, if we really cared that much, we could iterate through each number and see the maximum. So let's do I really care that much? Let me think. Yeah, why not? Okay, actually, it shouldn't take that long. So I think what we want to do is make a 2D array of the inputs. So the first 2 numbers would be xy for the beginning of the point, and then plus 2 numbers would be xy for the second end. And that should be that. So we just need to parse our inputs here. I'm just gonna copy this so that we have a visual representation. We don't have to go off memory. Yeah. Okay. So, I don't know, lines? What do they call it? Vents? I think it's hydro vents. Vents equal array. Sure, that'll work. Then for line in inputs array, we're gonna split this twice, I think. So once with this, and once with the commas, and then we're gonna parse each int separately. So that makes sense. We could replace. Actually, we could just replace this with a comma. So I think, yeah, that should be fine. Line dot replace, and then we're gonna do that arrow space, and then replace that with comma. Actually, we're gonna clone this and then replace it, I think. So new line. I don't really want to touch the old inputs. It doesn't really matter, just a good practice, I think. So equals line, and then new line dot replace. Does it replace in line? Actually, I don't remember. Let me see. Returns a copy. Oh, okay. So we don't really need to worry about that. Returns a copy of it. Right? Hold on. Let me read that a little bit more. Come on. You got it. Returns a copy with all occurrences of substring old replaced by new. Yeah, I think we're good. And then we're gonna delimit this. So vent chord chords. Is that a chord? C-O-O-R-D chords. I think I misspelled it earlier. Like I think I wrote chord like that. Okay, it's fine. Just sort of bugged me a little bit on the inside. I might go back and fix it later. Probably not, actually. I'm a little too lazy. Okay, would be new line dot split. And we're gonna split by comma. And then we're gonna do x, it'll be int x for x in new line dot split, and then close that off, and are we done? Oh, this needs to be a string. That should be done, and then we can just append this to the events. Dot append, and then let's print that out real quick. Events. Maybe I should do the same thing here. Defined prints array, and array for line in array, just print the line and we're good. So let's print array. There we go. Test inputs 09598008 and all the way down. Yep. Okay, now that we have that, we could. Okay, let's check the bounds. Bounds, and then we'll make a 2D array with those bounds, I think. Boundaries. So bounds x equals 0. Actually, it would be min we'll do this. Why? Honestly, we can make this as big as we want, to be honest. This is just a little bit cleaner, I think. Can we? We might be able to collapse this into a 1D array. Or, yeah, 1D? One-dimensional array. Never actually tried that before. Do we really want to do that? I feel like we just check the x coordinates and then the y coordinates. Okay, we might do this. So, oh, okay. I think I have an idea. So we might one-line this. So min of this array of Can we one-line this? I don't think we want to be honest. Okay, X's. Y's. I don't know, I'm running out of names to call it. But yeah, so this would be X for X0 for X in vents. Actually no, it'll be X. No, that's right. Plus, does that work? I forgot how you combined. I mean, we can do it in 2 lines, I guess. Plus equals. Two. Yeah, okay. This is so stupid. Is it stupid if it works? Yes. The answer is yes. And this one be 3. And I should not be using the X. Let's do E. Yay! F2 doesn't work. Okay. Gotta make this harder for me, huh? It's already hard enough. Please. Okay. Oh, and that's 3. Plus equals. Can't forget that. So now we want min. We're gonna make this a tuple, maybe? Yeah, let's make it a tuple. X of X's, and then this one's Y's. Or no, max of X's, and same thing here for Y's. So these are the bounds. And we're gonna print the bounds. We don't really need the min, to be honest. I think we always start at 0. Otherwise, it makes it a little bit more complicated. Yeah, I don't know why I did that. Let's just do max. Print bounds of X and then bounds Y. And as long as it runs, I think it should be fine. Max. Come on, Max. What are you doing? Okay. 9, 9. 9, 9. Alright. Well, that all the unnecessary stuff is out the way. Let's actually let's try on the input, shall we? 989, 988. Alright. That's fine by me. Now we want to make a grid of these, which would be grid equals. I don't really like calling it grid, to be honest. Coordinates. Chords equal an array x. Is it this? X for X? Wait. Yeah? Wait. 0 times X boundary bounds X. Does this make sense? Or wait. Hold on. So this would be the one array. Would this work? Times bounds y. And then we need to print this out. So print array chords. Well, that's unreadable. Stop. Let's try something a little bit easier, shall we? Let's change these values, yeah. So x, let's make this like 10. I think it just copies a reference from the 1D array. That's what I'm hoping it doesn't do, to be honest. We're gonna check that in a second. So let's see, bounds x, so that's right. If we change one, all rows change. Okay, let's try that. Chords, 0, 1 is equal to 10. And let's see if that works. Wait, what am I doing? 0, 1. Yep, okay. Almost. I don't remember how you make the 2D array. In Python, at least. Time to Google. 2D array. It's such a weird thing to do. Bounds x for I in range of... Oh yeah, that's how you do it, right. I was thinking something like that, but I just couldn't figure it out exactly. Thank you. For I in range of... That's... Okay, let's see. Okay, there we go. Actually, wait. Would this be x then? Are these reversed? Hold on. No, X is down, right? So 0, 9. 0, 9. Okay. You know, I'm fine with that, I think. No, wait, is it reversed? Hold on. Well, that's strange. Zero, 9. 0, 1. Let's remove this. Technically, it works. This would be bound for... Hold on. I think I need to reverse these. Bounds for X. Yeah, I think this is bounds for Y. And then this bounds for X. Right. So now we can go to, wait. 0, 1. Yeah, now we can go to 10. I guess it'll be 9. 9, 1. And it should go down here. Okay. Yeah, that makes more sense. Right, now that that's out of the way, let's go back to our test. Should make it a little easier. And we still want the print. I think. Oh. I think we're gonna be printing a lot in this. So if we go, yeah, we gotta iterate through each of them now. For coordinates in events. What are we doing with this? We have to draw out a line on that array. So we might end up making like a new function for this, but I think we'll be okay. We'll do it if it comes up. Like I'm already starting to write it. So, okay, we just print the coordinates. And that should be fine. 0, 9, 5, 9. So, how do we... Okay, we ignore these, right? If they don't match up. So if we need to do a check. So let's make a function for that. Define vertical, or I guess straight? No. Straight? Not... I don't know what they call this. Horizontal or vertical. And then the coordinates. I don't know if I want to be lazy and just do this. Words. I probably don't, huh? Yeah, whatever. I'm the only one using this. So, if towards 0 and equal to, or not equal. Hold on. They have to both not match, right? Yeah, okay, so if towards 0 is not equal to chords 2, and I want to do it in one line. I usually don't, to to be honest. So chords 1 is not equal to chords 3. Then we return false. Otherwise return true. Wait, if they... That means these two match. Yeah, this is equal to if either or. Okay. Yeah, this is fine. Okay. When we do the inverse, it's or. And this works. Should work, at least. So, if not horizontal or vertical, the coordinates, then we just skip this, continue. And then, so if it is, then... Trying to do this. That's the wrong set of keys. Okay. Skip diagonals. Okay. Yeah, skip diagonals. I'm assuming that our input's just gonna be like horizontal verticals and then diagonals. Otherwise, that'd be pretty cool. I think. I don't even know how you would do that. You probably have to round? Maybe? Probably round down. Okay, and then... So these are horizontal and vertical. Just gonna write that down. Now, so we have the... Actually, maybe we should write the just grids, huh? Grid. Grid. Make it less confusing. Now, we're gonna mark it down on the grid. I think this is gonna be like a flip version of how it looks on here. Maybe, since we're going. No, this should be fine, right? 0, 9. Oh God. So it's gonna go 0, 9 here and down. Yeah, it's gonna be a little bit flipped, but we should be fine as long as we keep that in mind. Man, I'm really like putting off writing this. It's not exactly difficult, I don't think. So let's write it then. How are we gonna do this? Do we check if it's... Wait a second. Maybe, okay, maybe I should write two functions. So if it's horizontal, and if it's vertical. Define horizontal is horizontal. Words. Because we're gonna need to do that check later. I think. Yes. And then if it's not horizontal and if it's not vertical, that means it is diagonal. Okay. That should be fine. So if coordinates... So if it's... Wait a second. These are flipped, aren't they? Yeah, these are flipped on my array. I could just invert this so that we actually get the right input, but or right the same way. Should I do that? Because our conventions are the same. So x is x, y is y, and these the bounds should make sense. Yeah, I'm not gonna worry about it right now. Horizontal. So if 0 and 2 are the same, or it is the same, we return true. True. Otherwise, return false. And I don't really have to do it right here, or I didn't have to make a function, to be honest. It's fine. Is vertical. Okay. And then it's 1, 3. Alright. Don't need you anymore. I'm not gonna need this either. Okay, and then Okay, let's just start right. Define. So we're gonna need add to grid. I don't know. Mark grid. There we go. That should make more sense. Mark grid. We'll do the array. Actually, just call it grid. And then we're gonna do the coordinates. So then we're gonna write. If it is horizontal, if chords are horizontal, just makes it easier to read. Because if I just put this in here, it's not gonna make much sense. Else, LF is vertical. And then we're gonna write separate cases for these each. Should be fine. So then grid. I guess we return a grid, huh? So new grid equals grid. That should make a new instance. I hope it's not a new pointer. Otherwise we're gonna run into a... Actually, it doesn't matter that much. we don't touch grid, or we don't touch the original input at all. Yeah, that's fine. This is fine, he says. Okay. So if it is horizontal, we just get the first number. So that should be coordinate 0. Okay. And from... Or... Let me do this. It has to be inclusive from... Wait a second. I'm trying to make sense of this. 0, okay. Nine. The bottom right corner, 0, 9, or 9, 9. Number of lines at point. For example, 0, 9. So 0, 9 is this. So to 5, 9. This is 6 numbers. This one's inclusive. 0, 9, 1, 9, 2, 9, 3, 9, 4, 9, 5, 9. Yeah, it's inclusive. Okay. How am I gonna do this? Actually, this would have to be +1 then, wouldn't it? I'm just gonna add one, just to be safe. I think I do need it, honestly. So, for I in range of chords. Well, we have to find which one's the smaller one, right? Or is the left one always smaller? Oh man. No, it's not always smaller, is it? Yeah, we just have to find a smaller one, and then we'll go up from there, and I should remove all these. Get a little tighter. There we go. It'll be one from, yeah, there'll be smaller one to the larger one. So smaller coordinate equals larger. And then we're gonna write a function for that too. Oh no. Define smaller, larger chords. I guess it could just be a number, but it's fine. Actually, should we? Yeah, it should be two numbers. Num1, num2. If num1 greater than num2, return num1, wait, num2, number 1, right? So smaller one's always on the left, larger one's always on the right, else return num1, num2. And it doesn't matter if it's equals, because it'll always be smaller to larger. It'll still be smaller or larger. So smaller, larger. And we do chords 1 and chords 3. Range of the smaller coordinates to the larger coordinates is +1. Because we have to include the larger coordinates, I believe. Grid. So the first one's x, and x is going to be constant. So yeah, it's going to be grid chords. This is gonna make no sense. Chords 0 to I plus equals 1. And then we're just gonna do this for the other way, I think. And I hope that comes out correctly. So this is gonna be 0, 2. This is gonna be I, and then this is gonna be chords 1. And then mark grid. Oh wait, we should do new grid, right? Don't want to run into the same problem we did earlier. And then we go return grid. The new grid, at least. Okay, and then I guess we don't care about this. So we're going to change it to chords 1. Chords 1. Chords 1. Oh, this one, yeah. Nice. Nice catch. we are good, I think. So yeah, we can. I think we can ignore that now. I guess we just start marking, right? Yeah, mark grid. Mark grid. Or I guess grid equals mark grid. Grid. And then the coordinates. And then do a final print array of the grid. And I might have to swap those. So wait, this one? This one, don't need that. So 2, 2, 2, 1, 1, 1. 2, 2, 2, 1, 1, 1. There should be a line here, yeah? Let's make sure they're on the right line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10. 8, 9, 10. 9, 10. Okay, that makes sense. See, it's kind of hard to see. Here, let's copy this. How am I doing that? And instead of doing, yeah, let's reverse this. I in length of array. I think it's array 1. Array, like array 0. And for J in length of the array, we're gonna print JI. RJI. Oh. Now it's... Oh, yeah. Whoops. Come on. Int is not iterable. Oh, range. Range. Python. Yeah. I guess end equal none, and then do a print there. Okay, maybe that makes more sense. Does that match? Should I guess I'll put it in, huh? If this is equal to 0, we print a dot instead. Otherwise, we print this. Else. And we still need the ending. There we go. Okay. That looks a lot better. And that looks exactly like we have there. So I think we are good to go. What is it? How many points? At how many points do at least 2 lines overlap? Oh. Okay, so we need to count. We need to iterate through it and count how many times 2 or more. Yeah, that should be easy. So for... I guess we can just copy this, huh? Man, this looks so stupid. Do I have to keep doing it like that? I think I do. I mean, like... Sure, whatever. This is fine. This is fine. Equal to greater than 1, sure. Then we let's see. Overlap equals 0. Overlap. Actually, this is a little inefficient, isn't it? I think it is. If I reverse these, should be fine. But I would have to, yeah, I would do IJ. I guess efficiency doesn't really matter. I mean, we are writing Python after all. Oh, range. We still need range. Python! Yeah. That would be grid. Grid, and then I. And then this would be IJ, grid. Grid. It's greater than 1, overlap, plus equals 1. And then we just print out our count. 5. And 5. Let's go! Yeah, now we, let's do it on our actual inputs. Right here. I probably shouldn't have printed it. Yeah, go. 4, 7, 4, 5. Moment of truth. Let's go. Part 2. Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You need to also consider diagonal lines. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or diagonal lines at exactly 45 degrees. In other words, an entry like 1, 1 to 3, 3 covers points 1, 1, 2, 2, and 3, 3. An entry like 9, 7 to 7, 9 covers points 9, 7, 8, 8, and 7, 9. Concerning all lines from the above example, we'll now produce the following diagram. Okay, that's a bit more of a mess, but it shouldn't be too much more difficult. We did leave some room to add. You'll still need to determine the number of points where at least 2 lines overlap. In the above example, there's still anywhere in the diagram with 2 or larger. Now a total of 12 points. Consider all of the lines at how many points to at least 2 lines overlap. And okay, now it's just a matter of adding to right here. Okay. Just make it a little bit easier to parse. So let's write diagonal. Let's update this. There we go. Okay, how are we gonna do this? I have no idea, honestly. We have to figure out like which direction it's going. It's either gonna be if we do. Okay, if we always do what is it? If we always do like x direction always increases. Okay, okay. X direction always increases, so this would be the x. So we can do increases this way, or increases this way. So y would decrease or this in this scenario, and y would increase in this scenario. We could do that. I don't know if that's helpful. Does it help? I think there's 2 separate cases for that. I Okay. It would be easier if we knew. Yeah. No, I'm not gonna look through all that and try and find them. But let's see. Man. My brain. I just can't do it. Okay, just start commenting. Find smaller coordinates. And then mark from smaller to larger. And this should be the same thing here. Okay. Diagonal, man. I guess we could do the same thing. Yeah, find a smaller coordinate. It would have to be XY though. Yeah, we have to return the X and Y. Otherwise we mix them up. Actually, what happens when we do that? I think yeah, we could end up going the wrong direction. So like this one would end up being this one. So let's see. Diagonals. Okay, let's figure out. Do I make another like function to do it? Maybe. It's not too much work. Smaller, larger coordinates. Oh no, what have I done? Guess we can do this. It's gonna be horrible. So, x1. Does this make sense? Wait. That doesn't actually make sense, does it? Chord 1. I'm just gonna make them tuples, and then chord 2. So, if chord 1, 0, squared in chord 2, 0, we return chord 1, comma chord 2 in a list. I think a list makes more sense. Does it? Or we can have a tuple of tuples. I guess that makes sense too, since it's immutable. Yeah, that's the word I was looking for. So chord. Wait, if it's greater then. Why am I doing it this way, anyways? Whatever. It's a little backwards, but this is okay. And then we do the opposite, chord 1, chord 2. Okay. So, find smaller coordinates. And sort of exactly the same thing. Sort of the same thing. Smaller, larger x coordinates. I'm gonna go with tuple 1, tuple 2. Chords 0, chords 1 and chords 2 and chords 3. So the X should always increase now. Yes, X always increases. Y can decrease. And then we're gonna have to have a separate case for that. So if Y increases, do we have to test for that too? Oh no. Hold on. hold on. Do we want to test for that here? I'm not sure how to do this. So, okay, I think we just check the smaller coordinates y, larger coordinates y, and we do it accordingly. So if a lot smaller coordinates smaller coordinates 1 is greater than smaller. Do I need to do this? I think I do, right? I don't know. I don't even know anymore. But enough of this. That's kind of fun. It's just, I think my brain's rotting now. Need some sleep. So, smaller coordinates. X always increases. So, would it be like this? Wait. Yeah, it'd be like this and this. This and this. If we're looking at the grid we had earlier. This and this. X always increases this way. Yes, that makes sense. Oh god. So, smaller coordinates. Oh, this would be less than, no? And then y decreases. Else. Now we gotta do new grid. Okay, for I in range of be smaller coordinates. Why am I even doing smaller coordinate? Shouldn't be smaller x. I don't think it matters too much. It gets a little confusing though. To smaller coordinates. No, larger coordinate. 0 plus 1. For I in range, okay. Then for j in range of, it's gonna be the same thing here. But then this one's gonna be 1. It's gonna be 1. And then we're gonna do grid, or new grid, I should say. I, j, plus equals 1. And then we're gonna do the same thing here, except we're gonna do this one backwards. larger. Wait, no, huh? Wait, huh? Would it be this? -1? Because this one's larger. So we go down to the larger coordinates. Yes. Yeah. Okay, I think that makes sense. Okay, now... Yeah, let's test it. I think that works. Run. I should clear this. 78. That is totally not right. Oh god. Right? Hold on, what? What's happening? 78. How do I get 78? What is happening? Oi. Oh. Wait, what? Is there... Huh? How did that happen? This is a mess. One larger coordinate 1 plus 1. Oh no, would it be -1 then? I mean, I don't think that matters. No, it's +1. It's still +1. Right? Or, that's not the problem. That's not the problem. Birdies! Priorities. Okay, well, let's break after the first one. Let's see what happens. Or actually break after the third one, huh? It would be this one. Second one. Actually, I think we can just delete these, to be honest. And we should see what happens. I'm gonna need to copy and paste that back, but... Yep, that is wrong. Oh, wait. Oh, I know. It's trying to iterate through all of them. We don't actually want that. So, that and that. Well, I don't know which one's which. So, okay, it'll be 0. Is that right? No, no, it'll be in range of isn't it I? I forgot how you do this. Diagonals. 1, 1, 2, 2, 3, 3. If it's the other way, it'll be 8, 8, 7. Okay. It would just be the one number, right? Why can't I think right now? We don't have 2 for loops. Yeah, We don't actually have four or two for loops, I should say. It would be... So, okay, doing this, right? J... I don't remember. Oh, they shouldn't be nested for loops. Yeah, I just realized that. I couldn't... Hey, hold on, I'm trying to remember how you do this. It's just one for loop. And then... Do we just decrease J? Or increase? Hold on. Y increases. So... J equals... My brain can't handle this. 1. And then what we do is J plus equals 1. Let's see if that works. Oh, it's this one, isn't it? Oh, let's just copy this. Get rid of the U. J equals smaller coordinates. And then J minus equals 1. There we go. Okay, let's try it the other way. Wait, is that 8 0 to 0 8? That's right, that's right. If we do... What's the other way? 0 0 to 8 8, huh? 8 8. There we go. Okay, let's see if let's try some numbers in between. Okay. Let's try 1 1. Yeah, that looks promising. I don't think that's how you're supposed to do it, but you know, this works. Okay, let's try on a test file again. I need to copy the thing back. Real? Okay. Wait. Wait a second, what? That is not right. What's happening here? Oh wait, oh right, this break statement. Oops. Okay, that looks promising. I think we've got it. And we have a 12, just like they have. Okay. Now for the final test. Moment of truth. God damn it. Stop with the prints. 18,442. Let's go. And just like that, we're done all 5 days. Yeah, there's 20 more to go. I don't know if I'll be finishing up. I don't know if I have time, to be honest. But yeah, that was fun. Hope you guys enjoyed it as well. Except for another hour. No, I think I'm okay. Yeah. Thank you guys for watching. Have a good night, and goodbye. That's an echo. Oh, and thank you for following. Nimbin Goth. Oh, yes, me.